Hi, my name is Abdulmalik Kumar, and this is my demonstration for Lab 8 of Com4601. The goal of this lab is to compute the mean absolute error of a recommender system using the leave one out evaluation strategy. The idea of the leave one out strategy is that for every rating in data sets, we're going to pretend that we don't know it, and then we're going to try to predict it using the rest of the data and measure how far off we are. So basically, if user 5 rated item 200 with a 4, we temporarily set that rating to 0, or run the recommendation algorithm to predict what user 5 would give the same item 200, and then compute the absolute difference between our prediction and the actual value of 4. We're going to do this for every single user and item pair in this data set. In our case, it's an average or the errors to get the MAE. The key thing about leave one out is that we have to be careful not to let the rating we're trying to predict leak into the calculation. So when we compute user use mean rating as a fallback, we exclude item I, and when we compute Pearson similarity between user U and the neighbor, we must also exclude item I from user use ratings. Okay, so let me go through my lab 8 code. Okay, as we can see here, the load data function reads the file and passes it into a num-p matrix R, where the value at row U, column I, is the rating of user U for item I, or 0 if unrated. The main logic is in this compute MAE function. This is where I loop over every user, and for each user, I'm going to get the list of the items they've rated using mp.where. Then for each of those items, this is where the leave one out happens. I'm going to make a copy of user use ratings called u_exl, that's here, and set its position to 0, effectively hiding the rating we want to predict. We then compare user use mean over the remaining ratings. I use this as the base for the prediction formula and as a fallback if we can make a proper prediction. Next, I find where the candidate neighbors are. These are all the users who have rated item I, and we only need to consider users who rated item I because they're the only ones who can contribute to predicting it. For each candidate V, I'm going to compute the Pearson correlation between user use ratings with item I excluded and users V's full ratings. I then find the items that both users have rated, that's the correlated items here, and compute the standard Pearson formula, that's sum of all products of deviations, divided by the product of the standard deviations. If there are fewer than 2 correlated items, we can't compute a meaningful correlation, so we set the similarities to 0. Okay, so once we have similarities for all the candidates, we need to pick the top k. I use the top, up to the top 5 k's. By absolute similarity value, I use absolute value because strong negative correlations are also very informative in this sense. I then compute the prediction using the weighted deviation formula. Okay, some edge cases I handled where if the denominator comes out to 0, that is if all the similarities were 0, well, I'm going to fall back to user use mean, and after computing prediction, I clamp it to the range 1 to 5 since those are the valid rating bounds. Okay, so I'm going to now run my code so you can see the output. My system is taking a little while, that's why I wasn't even able to record the video on my laptop. So once the result loads out, I'll let you know. Okay, so you can see it printing the progress for each user. And it's done. Okay. So basically, this shows how many items each user rated, the running MAE, and the estimated time remaining. And the final results, the final MAE results, is about 0.7873, which is around the target of 0.77 that was required for the lab spec. For optimizations, I would say maybe rather than computing the similarities against all the other users for every prediction, what if we only compute against the users who actually rated our item? That's going to be a much smaller number and make this run more efficiently. So thank you for watching my video on my lab 8 assignment, and yes, that's it. I just realized you couldn't see the MAE results from the last recording. Okay, so here's the MAE results, which is 0.7873. Thank you very much for your time.